So it's important to recognise that reserves have this very specific economic meaning. It's not a fixed figure and it's dynamic. For example, reserves can increase where extensions of an existing mine are discovered, or, for example, if the price of a commodity increases, there might be more exploration, therefore resulting in the discovery of more deposits. In this example, you can see that where the price increases, the proportion of the deposit that becomes extractable increases, and the opposite is also true. If the price of a commodity drops, there's a risk that it becomes no longer viable to extract. Recent research shows that global reserves for most metals have not significantly decreased relative to production over time. This is because exploration has identified more ore bodies and replenished exhausted reserves. Reserves are dynamic entities and represent only a small proportion of crustal resources. Science-driven exploration and development continually replenishes reserves from previously uneconomic or undiscovered resources. Reserves fail as an indicator of long-term availability, as their definition depends on current science, technology, and economics. This is a good example of a critical raw material, in this case cobalt, where reserves are consistently greater than production. Exploration and the delineation of reserves are filling the gap between current known reserves and predicted future demand. Another important thing to consider is the distribution of resources. Looking again at this example of cobalt, we know that most of the global production is in the DRC. This concentration of production results in potential risk of supply interruption. However, it's also important to consider how well have we explored the rest of the world for potential resources, and how well do we understand how cobalt deposits form. This underpinning data is key to future development of resources and reserves. It also highlights again that the current resources and reserves only represent what we know at a singular point in time. Although primary metals are non-renewable resources, most geologists consider that the physical exhaustion of metal in the Earth's crust is very unlikely in the foreseeable future. In the case of critical raw materials, geological scarcity is not usually the problem, and as such we are not going to run out of resources. Of greater concern is the concentration of production into a few countries and potential bottlenecks in the supply chain. Many factors, including the environment, land use, geopolitics, societal acceptance of mining, energy and water demand, declining ore grades, economics and ethical issues are likely to be the main sources of risk to metal and mineral supply over the coming decades, more so than direct reserve depletion.